This is a 440 hertz sine wave test and 440 hertz inverted sine wave test. And this is to reduce noise by counteracting one noise with another. 440 hertz sine wave. Now we have the 440 hertz sine wave with a 440 hertz inverted sine wave. Now the next one is the inverted sine wave. Then back to the 440 hertz sine wave, 440 hertz inverted sine wave, and we're going up and down with the volume to see how it cancels. I hope that was interesting.
Noise reduction in large-scale battery energy storage systems.
Right.
By the end of this, you'll understand how cutting-edge tech is making these green energy powerhouses a lot more neighborly.
It's a fascinating challenge, isn't it? Trying to balance the need for clean energy with the very real concerns of the people who live near these systems.
Absolutely. Speaking of real concern, let's start with the basics.
Okay.
What is a decibel? And why should we care about it when it comes to these massive batteries?
Okay, so a decibel, or dB, measures sound intensity.
Okay.
To give you some context. A whisper is about 30 dB.
Okay.
A normal conversation is around 60 dB. And that garbage disposal running in your kitchen is closer to 80 dB.
Okay, so that's a good scale to think about.
Yeah. And the reason this matters is that we have noise limits.
Right.
Especially in residential areas.
Makes sense.
It's all about protecting people from excessive noise pollution.
Right. Makes sense. In fact, I remember reading that the UK has some pretty specific nighttime noise regulations.
They do.
Something like 30 to 45 dB, depending on the area.
Exactly. And that makes perfect sense when you consider the impact noise can have on sleep and overall quality of life.
For sure. So how do these stir up? Are they whisper quiet?
Okay.
Or are they closer to that garbage disposal we were talking?
Showed a noise level of 84.6 dB at 8 hertz. That's louder than a garbage disposal.
Yeah.
And definitely exceeding those nighttime limits we were just discussing.
Yeah, so this noise level clearly exceeds the limits. What are the real-world implications of this for like a project?
So imagine you're a developer.
Okay.
Trying to get permits for a new energy storage project.
Yeah.
This kind of noise level could easily become a deal breaker for local communities.
Oh, for sure.
Leading to costly delays or even project cancellations.
Wow.
Not to mention the potential legal battles and the damage to a company's reputation.
Yeah. So noise is clearly a big deal.
Yeah.
What's actually causing all the racket inside these battery systems?
There are multiple culprits at play. The main offenders are the cooling fans, the pumps, and the inverters.
Okay.
All of these are essential for the system's operation.
Right.
But they also generate a lot of noise.
So it's like a whole symphony of mechanical sounds.
You could say that.
Okay.
You've got the whirring of the fans, the hum of the pumps, pushing coolant. And then there's the inverter, creating a constant electrical hum.
So it's not just one type of noise, but a combination of different frequencies all happening at once.
Exactly.
That seems like a pretty complicated problem to solve.
It is. And that's why tackling this noise problem requires a multifaceted approach. Speaking of specific solutions.
Okay. I know there are two main approaches to noise reduction, passive and active. What exactly is the difference between these two?
Okay, so think of passive solutions like soundproofing a recording studio.
Okay.
You're using sound-absorbing materials, things like acoustic foam, to absorb the sound waves.
Okay.
And then you've got vibration dampening techniques to stop those vibrations from spreading.
Yeah.
It's all about creating a noise-proofed cocoon around the noisy parts.
So it's like trying to contain the noise at the source?
Exactly.
But what about active noise cancellation? That seems a lot more complex.
Active noise cancellation, or ANC, is a bit more futuristic.
Okay.
It's the same technology used in those noise-canceling headphones.
Right.
You see everywhere these days, just on a much larger scale.
I love my noise-canceling headphones, but how does that work with a giant battery?
Yeah.
I mean, they aren't exactly portable.
It's actually surprisingly similar. You strategically place microphones near the noise sources to pick up the sound waves.
Okay.
Then a DSP chip, think of it as a tiny brain, analyzes those waves and figures out their frequency and amplitude. That intel then gets fed to the DSP,
Okay.
It's a specialized microchip that analyzes the incoming sound waves and decodes their frequency and amplitude. Think of it as a code breaker, figuring out the secret language of noise. Once the DSP has cracked the code, it generates an anti-noise signal.
Okay.
This signal is essentially an inverted copy of the original noise, but with opposite phase.
So it's like creating a sonic mirror image, but flip upside down.
And this is where the speakers come in. They're like the voice of the system, emitting these carefully crafted anti-noise waves.
Okay.
When the original noise and the anti-noise collide, they cancel each other out, resulting in ideally silence.
So it's like a sound wave battle, and silence is the victor.
You got it.
But I have to ask, wouldn't this just create more noise?
Yeah,
Adding more sound to cancel out sound seems counterintuitive.
that's a common misconception. Remember that destructive interference we talked about earlier?
Yeah.
These opposing sound waves don't actually add up. They subtract from each other. It's not about creating more sound. It's about strategically manipulating existing sound waves to reduce the overall sound intensity.
Okay, that makes sense. But wouldn't you need a massive speaker system to counteract the noise from a giant battery?
Right.
It seems like it would need to be pretty powerful.
Not necessarily. The beauty of ANC is that it's most effective at targeting specific frequencies.
No, okay.
So instead of trying to cancel out all noise indiscriminately, we can focus on those dominant frequencies that are causing the most trouble.
How do they figure out which frequencies to target? It seems like there would be a lot of variables to consider.
That's where the initial noise analysis comes into play.
Okay.
Remember those detailed measurements and frequency spectrums we discussed earlier?
Yeah.
That data is crucial for identifying the main culprits. We know those 8 hertz, 250 hertz, and 500 hertz frequencies are the ones we need to tackle.
Right, because those frequencies correspond to the fans,
Yes.
the inverters, and other noisy components.
It's all about understanding the noise profile of the system and tailoring the ANC system to address those specific issues. And of course, the beauty of AI is that it can continuously monitor the noise and adjust the ANC system on the fly,
Oh, wow.
ensuring optimal performance even as the battery's operating conditions change.
So it's like having a dedicated sound engineer on duty 24/7,
Yeah,
constantly tweaking the mix to maintain a peaceful soundscape.
exactly.
But ANC is only one part of the solution, right? We were talking about passive noise reduction as well.
Absolutely. Passive noise reduction techniques are equally important. Remember those sound-absorbing materials and vibration dampeners. They play a crucial role in reducing the overall noise energy within the container.
Right. It's like building a soundproof fortress around the noise before it even has a chance to escape.
You could say that. Think of it as a multi-layered defense against noise pollution with passive and active measures working in harmony.
Okay, this is all fascinating, but can we get into a specific example of how all of this comes together?
Absolutely.
Yeah.
Let's take the cooling fans as an example.
Yeah.
They're one of the main noise sources, producing a lot of noise at that troublesome 8 hertz frequency. So to tackle this, the engineers are considering a few different strategies. First, they could simply replace the existing fans with quieter models.
Okay.
Technology has advanced, and there are now high-performance fans specifically designed to be much quieter. But sometimes replacing the fan entirely isn't feasible or cost-effective.
Okay.
In those cases, we can turn to other solutions like vibration isolation. By installing special mounts or dampeners, we can prevent those fan vibrations from being transmitted to the container walls and radiating outward as noise.
So it's like giving the fan its own set of noise-canceling shock absorbers, isolating it from the rest of the structure.
And if those measures aren't enough,
Yeah, okay.
we can add a layer of active noise cancellation.
Okay.
Microphones strategically placed near the fans would pick up that 8 hertz hum. The DSP would generate an anti-noise signal,
Okay.
and speakers would emit those counterwaves to cancel out the noise.
So it's a three-pronged attack. Quieter fans,
Yes,
vibration dampening, and active noise cancellation.
it's all about tailoring the solution to the specific noise profile of each component.
This is starting to feel like a high-tech game of sonic chess.
Yeah.
You have to think several steps ahead to anticipate and counter the noise.
It really is a strategic process of identifying the noise sources, analyzing their frequencies, and then deploying the right combination of passive and active techniques to achieve the desired level of silence.
Okay. But now I'm curious about how they actually put all this into practice.
There you go.
We're talking about a giant battery system, not a pair of headphones. How do they physically install and implement all of these noise reduction techniques?
The implementation process involves a lot of careful planning, engineering, and collaboration. It starts with the detailed acoustic design of the container itself. The engineers have to carefully consider the placement of microphone speakers,
Right.
sound-absorbing materials, and vibration dampeners. They use sophisticated computer models and simulations to predict how sound will travel within the container and optimize the placement of these elements for maximum effectiveness.
So it's like designing a custom-built sound studio, but for a battery? That's a pretty specialized skill set.
It is. They also have to consider things like airflow and ventilation.
Right.
You don't want to trap heat inside the container while you're trying to silence it.
Right. That would be a classic case of solving one problem and creating another.
Exactly. So it's a delicate balancing act.
Yeah.
But once the design is finalized,
Yeah.
the actual installation process is relatively straightforward.
Okay.
It involves mounting the various components, wiring everything up, and then testing and calibrating the system to ensure it's performing as expected.
So it's like building a giant noise-canceling Lego set, but with slightly higher stakes?
That's one way to put it. But the key takeaway here is that implementing these noise reduction systems requires a truly collaborative effort between acoustic engineers, battery system designers, and installation technicians. It really shows how seriously the industry is taking the issue of noise pollution.
It's encouraging to hear they're putting so much effort into mitigating this problem. But even with all this amazing technology, there must be some challenges and limitations, right? Can these systems actually make these giant batteries completely silent?
While these technologies hold immense promise, they aren't without their challenges. Let's explore some of the complexities and potential limitations of noise reduction in energy storage.
What are some of the hurdles engineers are facing?
Well, one of the biggest hurdles is cost. High-quality microphones, powerful DSP chips, robust speakers. These components all add up, especially when you're dealing with a system the size of a shipping container.
What about ongoing maintenance? Is that a factor as well?
Absolutely. These systems need to be calibrated and adjusted over time to maintain optimal performance. Think of it like tuning a piano. You need to make sure everything is in harmony for the noise cancellation to work properly. It's not a set it and forget it kind of solution.
So there's continuous upkeep involved. Are there any other challenges that come to mind?
Yet dealing with unexpected noise sources is a big one. Remember how we talked about those different components, each with its own unique noise signature? Well, sometimes things get a bit unpredictable. A loose bolt, a worn-out bearing, even the wind whistling through a gap in the container can throw off the entire system. That's where AI and machine learning become even more critical. They can help the system learn and adapt to changing conditions, making it more robust and effective over time. It's like having a self-tuning noise-canceling system, constantly monitoring and adjusting to maintain optimal performance.
That's remarkable. But even with AI, are there limitations to what these technologies can achieve? Can they really make these giant batteries completely silent?
While these technologies are incredibly effective at reducing noise levels, they can't eliminate it entirely. There will always be some residual noise, especially at very low frequencies.
So you're saying we might still hear a faint hum, even with all this incredible tech in place?
But remember, the goal isn't necessarily to achieve absolute silence. It's about reducing noise to acceptable levels, levels that comply with regulations and don't disturb nearby residents. And in most cases, these technologies are more than capable of achieving that goal of peaceful coexistence. They represent a significant step forward in making renewable energy storage more compatible with our communities.
Okay, so we've covered the challenges and limitations. What about the future of this technology? Where do you see things going from here?
The future of noise reduction in energy storage is incredibly exciting, but there's also a lot of research being done on new materials and technologies that could further enhance noise reduction capabilities. Another promising avenue is using piezoelectric materials for noise cancellation. These materials generate an electrical charge when subjected to mechanical stress, like sound waves. This charge can then be used to power a counteracting force that cancels out the noise.
Wow. So they're using the noise itself to power the noise cancellation.
That has the potential to be incredibly efficient.
This is all so fascinating. It really paints a picture of a future where these energy storage systems can seamlessly integrate into our communities without causing disruption.
I agree. These technologies will play a crucial role in making that transition smoother and more harmonious. Hopefully you've gained a deeper understanding of how these systems work and the crucial role they play in our energy landscape.
There's a whole universe of fascinating technology out there waiting to be discovered.
So stay curious,
Yeah.
keep learning, and who knows, maybe one day you'll be the one developing the next generation of silent energy solutions.
Thanks for joining us.